Alright, let's dive in. Today we are looking behind the scenes at one of the coolest and honestly most confusing part of Node.js, the event loop. It is absolute magic ingredients that makes Node so incredibly fast. So let's get right to it. So you got to start with this question, right? It's the biggest puzzle in Node.js. We are always told it's single threaded. That means just one line, one process, one thread running your code. So how in the world can it handle thousands of users at the same time without freezing? It sounds totally impossible, kind of like one waiter trying to serve an entire stadium of people. And this is where the example just clicks. Instead of hiring thousand waiters, which would be like thousand threads, Node says, "Nah, let's just get one super fast waiter." See, this waiter doesn't do any of the cooking. They just zip over the table, take the order, pass it to the kitchen, and then immediately, and this is the key part, immediately move on to the next table. When the food is ready, the kitchen rings a bell, and our waiter just swings by to deliver it. That's right. There is the event loop is in nutshell. Okay, so to really understand how that waiter pulls it off, we need to meet the key players working behind the scenes. It's not just one thing, it's the great team setup where a few different parts work smoothly together. Now, inside Node, there are two main parts we really need to care about. First, you have got Google's V8 engine. You probably know this one. It's the muscle that actually runs your JavaScript. But the real hero of our story today, the second key player, is a C tool called libuv. This is what handles all the background works. Let's break it down like this. V8 is the JavaScript brain. It's where your code actually runs. It tracks what function is being called. That's the call stack. And it handles memory. But libuv is silent worker. It's the heavy lifter that deals with things like network request or reading files. And most importantly, it's the thing that actually builds the event loop. So, if libuv is our silent worker, let's step into its workspace for a second. How does it actually manage all these background tasks without ever stopping that main thread? Well, it has two really powerful tools. The main thing to get about libuv is that it acts like a smart middleman. It gives Node one simple way to handle all that background stuff. You know, reading files, making web calls without ever having to pause your main code. It just starts the task and basically says, "Hey, let me know when you are done." And for some of the harder, heavier tasks, it uses something clever called a thread pool. Wait a minute. Wait, I thought you just said Node was single threaded. And you are right. Your JavaScript only ever runs on one main thread. But libuv behind the curtain keeps a small group of backup workers on standby, usually 4 by default, who handle very specific heavy jobs that would totally block your main thread. So, what kind of heavy jobs? Well, for tasks that your computer can't do quickly in the background, like reading hard drives, libuv hands that job off to a backup worker. It also hands off heavy math stuff like password hashing or zipping files. The whole point is to keep our super fast waiter, that main thread, totally free to keep taking more orders. Okay, so we have met the key players. Now it's time to look at the main event itself, the event loop. And it's not just the one simple line, it's actually a cycle that has different steps or phases. Yeah, so the loop isn't just one big circle. It moves through a straight order of steps every single time, and each step has its own to-do list, its own line of callbacks. The rule is the loop has to finish every single task in one line before it's allowed to move on to the next step. Let's walk through it. First up, the timer phase. This is where any set timeout or set interval code gets run. After that, there is a quick stop for pending callbacks, which handles some system errors. Then we hit the big one, the poll phase. This is where Node checks for new stuff like finished file feed or web response and runs their code. After poll, it moves to the check phase, which is specifically for set immediate. And finally, the close callbacks phase cleans things up like when a connection is closed. Then the whole cycle start all over again. Now, just when you think you have got the whole order learned, Node throws a little trick at you. Turns out there is another super important system that runs just outside this main loop. You can think of it like a fast track for really urgent tasks. And this is usually when a good question comes up. Okay, but what about promises? We use them constantly with async await. They don't really seem to fit into any of those six steps we talked about. So where do they run? They belong to a special line called the Microtask Queue. And the most important thing to understand is how important they are. Microtasks, which are mainly for promises and another thing called process.nextTick, are more important than anything in the main event loop. They literally get to cut in line. Here is the absolute most important rule to remember. After any single task finishes in one of those main steps, but before the loop can move to next step, Node just stops everything and check for microtasks. First, it will run every single thing in the next tick line until it's empty. Then it will run every single thing in the promise line until it's empty. Only after all of that is done is the event loop allowed to move on. So, why do we care about all this inner working? Why does this matter? Well, because understanding this dance between weird, libuv, and the backup workers, the main loop steps, and that fast track, that is the key to writing truly fast, amazing Node.js apps. And it all leads us to number one rule, the single most important rule in all of Node.js. You have heard it before, but let's say it again. Don't block the event loop. Any slow, heavy code you write on that main thread is like our super waiter stopping to chat for 20 minutes with one table while the entire restaurant is on fire. It just brings everything to a dead stop. Learning this flow has huge benefits. Your app handles way more traffic. You stop wasting your computer's power and your users they get a much faster experience. Honestly, this knowledge is what separates developers who just use Node.js from those who can build truly powerful systems. So we have looked inside the engine. We have met the silent worker. We have done a full lap around the loop. We have seen how this single threaded setup can be so incredibly fast. So the only real question left is this. Now that you know the rules of the machine, how are you going to code differently?